Hi everybody, and thank you for coming to the Vitrage project update. It's good to see that we have people who are actually not on our team present in the room. So let us start. Let's first mention what is Vitrage for everybody who might not be familiar with it. Vitrage is an official OpenStack project that started about 2.5 years ago during the Mitaka release cycle, and when Newton started, we were accepted as an official OpenStack project. And what Vitrage does is root cause analysis of the problems you might have in your system. So the general idea is to get as much data possible from every possible data source, gather it, and use the business logic to create the root cause analysis. And of course, Vitrage will give you a holistic and complete view of the system. Well, this is what I was supposed to say right now. What I didn't mention is that right now we have 10 active contributors. Some work with us at Nokia and some don't. And we're always looking for contributors, so if anybody wants to write some code, you can come to our onboarding session later on and we can talk about that some more. So let's talk about what we did in Queens. We had some very good features done, and one of our main focuses was expanding existing functionality. And we've added dedicated notifiers for Nova, SNMP, and Mistral. That was one of the highlights of the Queens release, actually. We've integrated Mistral workflows that can be executed from inside Vitrage, based, of course, on the business logic and the templates. And we also created APIs for registering to Vitrage alarms, either by resource ID, by alarm name, like regular expressions, and we have HTTP callbacks for each alarm. Another new thing is the alarm banner, which was contributed by our friends at Wind River. And the moment you have Vitrage active in your OpenStack, the alarm banner will pop up in Horizon, which will show you straight away, even without looking at Vitrage, what kind of alarms exist in the system. And if you click on the banner, it will just take you straight to Vitrage UI, which sometimes might be hidden somewhere, depending on the actual implementation of OpenStack and what kind of skin you have. So in our case, it's pretty visible, but sometimes it can be hidden away. So that's a very cool feature. And the other features that were done under the hood, which might not be huge and glorious, we did a lot of performance improvements. And that was one of our weaker points before the Queens release, where if we had a lot of different entities in the graph, sometimes we get sluggish. So now we optimize memory usage, and we've tested everything with up to 60,000 different objects in the graph, which actually can be represented in real-life scenario in a cluster with over 100 physical compute nodes, each one running at least 5 to 6 VMs, and each VM having 5 to 6 network interfaces, for instance. There is a new SNMP parsing service, and we did a lot of enhancements for our templates. So there's an API to add and release templates instead of just restarting the service like it used to be in the past. And you can use regular expressions, functions, and includes inside the templates. And now for future versions and developments, I'll let Ifat take over.
Hi. So I'm Ifat Afek, I'm the PTL of Vitrage, and we'll talk a bit what we are doing now, these days. This is currently an ongoing effort of improving the high availability of Vitrage. It was started in Pike, where we did the design and started the implementation. Our main goal is that if you have Vitrage graph that is down for one reason, you start a new Vitrage graph process, and we want to make it start as fast as possible. And we are doing it by persisting the events that arrive to Vitrage. And once in a while, we persist a snapshot of the entire graph. Maybe I should add as a background that we use in-memory graph database, Network X, which works very well. But we need to handle the persistency in an alternative way to make the recovery faster. So in Pike, we added a collector service. We separated the data collection from the graph processing to make it more independent and more robust. In Queens, we wrote the code that persists all the events and the snapshots periodically. And now in Rocky, we started writing the code that actually loads the information. The idea is that once Vitrage graph process is started, we load the latest available snapshot and then play back the events that happened afterwards to recover to the current state of the graph. Alarm history. We have several reasons why we want to keep the history of the alarms. As I said, currently we hold in-memory graph of the current state. But we want to be able to show you root cause analysis also for alarms that happened yesterday maybe and are already recovered, but you might want to learn from what happened. You may want to do some statistics, see if one alarm happens more often. And in the future, we might also use this information for machine learning capabilities. And the way that we implement it, we are using a relational database just to make it easier for smart queries and easier to store it. And we will store only a small part of the information. So we don't plan to store a graph in a relationship database. All we care about is the properties of the alarm and its relation to the resource. And maybe the relations between different alarms. But, and this information will be smaller information, so we will be able to store it for a longer period. We are adding Kubernetes and Prometheus data sources. I don't think I need to explain why Kubernetes is needed, both for Kubernetes environment and for hybrid environments with OpenStack. We are now showing in Nokia booths a live demo of Vitrage with Kubernetes and Prometheus. This code is about to be committed upstream in the coming weeks. This is a snapshot from the demo, where you see the Kubernetes nodes that are actually running on top of Nova virtual machines. And Prometheus is the most common monitoring system for Kubernetes. And we added it also as a data source, so we receive alarms from Prometheus, and we can correlate them, for example, with alarms coming from Zabbix or other alarms. And the advantage of Vitrage here is that we know about the relations between the Kubernetes cluster and the infrastructure of OpenStack, because we hold the entire topology. And we can use this information to provide more insights about the system. We are about to add a new feature, a new capability of running actions from the Vitrage entity graph. This is currently in code review phases, last phases of code review. We are going to add an action panel as in the red circle, and it will be based on your selection. If you select, it's customizable. You will be able to execute different actions. If you select an alarm coming from Zabbix or Nagios, you can open the Zabbix or Nagios UI. If you select a resource, you can execute a Mistral workflow. Mistral is the OpenStack workflow service. And by executing a workflow, you can, for example, do some healing process or run additional health checks from Vitrage in the context of what you selected. So it's very powerful, and it should be very easy to add other types of actions if you feel that something is needed or might help you. We also have some cross-project work that is ongoing. There is a new SIG group, special interest group in OpenStack that was formed a few months ago. I don't remember exactly when. And the purpose of this group is to see how different projects in OpenStack can collaborate and can together form a solution for self-healing in OpenStack. So there are ongoing discussions, and we participate in the discussions, trying to give like best practices or set of use cases and how they can be addressed. We are working on an integration of Vitrage and Congress. Congress is a policy service in OpenStack. So I didn't mention earlier, or actually Yuval mentioned it, that we added an ability from Vitrage to execute Mistral workflows. We also want to be able to pass information to Congress, so Congress policies will be evaluated based on Vitrage insights. And we are considering also integration with Munaska and other integrations. I think that any connection of two projects in OpenStack can be beneficial. And that's about it. I think it was faster than 20 minutes. We will be happy to answer questions and also to get ideas about new features you think we should add, maybe start planning the next release. So any feedback is welcome.
One quick question.
Yeah.
At this current time, is there no way to look at what happened, for example, last week, so we could?
No, but it will be in Rocky.
Okay.
Yeah. Yes?
Just had two questions. First was, could you give some examples of the type of issues that Vitrage would have diagnosed? I know you have something there with Kubernetes, but could you have any other kind of common OpenStack issues that you would use Vitrage for?
Yeah, so currently in Nokia Boost we have two demos. One of them is with Kubernetes. We are causing stress on the CPU. And we got two alarms for it. One alarm is from Zabbix, which monitors the CPU of the host. We got a warning that the CPU is increasing above the threshold. And also, we use Prometheus to monitor one specific service this specific service is performing a mathematical calculation, but it could be a service that is critical to your organization. And in Prometheus, you see really a very the graph of the performance, you see that the service really stops functioning almost. And then we get a critical error from Prometheus. And we know that the worker node of Prometheus is running on the host that has a high CPU load. So we correlate these two alarms because we know the topology. This is our additional value. And because we know the topology, we say, OK, so Zabbix said that there is a warning, but we know that already one service is in severe state. So we raise another alarm saying the host iCPU is a critical error, and you must handle it now. This is one example. The other example, the other demo that we are doing is that we are causing a network failure. We are bringing down two network interfaces. And we know the topology that these interfaces affect the tenant network. The VM is unreachable. And as a result, there is a heat stack that is using this VM. So the heat stack is affected. And there is a VNF that is also affected. And we notify the Nokia VNF manager, CBAM, Cloud-Based Application Manager. And as a result, it starts a healing process. And it evacuates the failed VM to a host that is available and healthy. So the failed host is still unreachable, but the VNF is no longer affected.
Yeah, that's great, thanks. And just the other one was,
yeah.
Is there much or any overlap with something like Salamander and A?
No. So in the beginning, we started in Mitaka cycle. And first thing we did before starting was going to talk to the PTLs of Ceilometer. And we went and talked with them and asked if they are going to do something like this, because we didn't want to overlap. So Ceilometer is based on monitoring and metrics, and we don't do monitoring at all. We just collect from different monitors. We collect alarms and topology and correlate them. We are not in the monitoring is a huge area, and we don't get in there.
Yeah,
and
actually, we're integrated with the AODH because we have a data source to get alerts from AODH, and we'll display those alerts in our graph, in our topology, and we can use these alerts to create additional deduced alerts. So for us, that's a pure data source.
Yes. And all the way we communicated with A, and
That's really
Yeah. Any other questions? Well, thank you very much. We'll be happy to see you in our later sessions.